have an animation that I want to make sure you guys see. But hello, everybody. I'm Brenda. I'm one of the co-founders of Tellor. We've been live on an EVM environment since August 2019, and this is our first build on the multi-chain environment. So I'm excited to present our architecture. And I really want to find out through this presentation what you guys are building and whether or not this is something that you can actually use to bridge data on Polkadot. So this is how we actually did our first implementation. But first, I'm going to give you a full overview of how it works. And in general, with the economic incentives, it is an open system. It is trustless. And we wanted to continue that design in Polkadot. We had to implement it a little bit different, but in general, this is how it works. So for Tellor, anybody can become a data reporter as long as they stake. And they risk losing that stake if they provide bad data. But once they're staked, they can start providing data on chain, and anybody can come and dispute the validity of the data for a fee. And if they're successful on the dispute, they get to take the whole stake. Otherwise, the data reporter gets the dispute fee for their troubles, right? And then as a user, you can come and request any type of data that you need. You have to specify what you need. You have to provide a definition, aggregation, anything that you need. And it has to be clear enough so that data reporters are willing to provide you the data without thinking that they're going to be disputed and that the data is not going to be considered valid. So you have to think about this. We're happy to help you come up with a robust solution and a robust data information so that you don't get, hopefully you don't get hacked. Do not use like a single API, please. But anyway, you can come once you provide a definition and everybody knows what you want or what you need. Currently, it's basically a PR on GitHub. We are decentralizing that into IPFS so that everybody that's staked knows what you need. Anyway, once you do this, you can start providing payments or posting payments on chain, and that signals to everybody that's staked that you need your data now. And they rush to provide it because only the first one to provide the data gets to claim that reward. And then once the data is on chain, once the data is on chain, then you can go and read the data and do whatever it is that your protocol needs to get done. Once it's on chain, anybody can use it. It's open for anybody. So if it's a very popular feed, it's going to be a lot cheaper for you to get it more often because other people also need it, right? And the way that we implemented this in Polkadot is we had to split it into two portions. We have the Tellor core portion that's actually going to live on an EVM chain. And it's not just an EVM chain for Tellor. It could include other stuff like Moonbeam, you know. But in essence, what it holds is basically the governance mechanism for the dispute settlement and also all the staking. And that's basically the Tellor core, what I'm calling the Tellor core parachain. And then anybody, we have a substrate palette that anybody that, you know, I guess launches a parachain, they can decide to implement Tellor and provide or allow their users to use Tellor as a bridge for data. Once they implement the palette, they do have to come back to the Tellor core and register it so that they can actually start communicating through XCM. And once they're registered, anybody can come and stake. And they do have to stake or provide a stake per chain, per parachain. So they have to provide the parachain ID so that once they stake, then XCM can go and tell that parachain that they are staked and that if they provide bad data, that they can be slashed and that they can be allowed to start providing data there. And then on the parachain side, consumers can come and start posting tips on the native token of the parachain, and anybody that's staked will be able to provide the data. The dispute for the validity of data always begins on the parachain side because that's where it lives, the data lives. Once a dispute is initiated, then it goes through a vote, and the vote is the way that it's resolved. It's equally weighted among four parties, the Tellor, TRB holders, the team, the, the users, and the data reporters. And this is done that way because that way if somebody wants to break the vote, they actually have to take over 2 of the user groups to be able to break it. And the users and the data reporters will vote on the parent chain, and then the Tellor TRB holders and the team wallet will vote on the Tellor core parent chain. And the Tellor core team wallet generally will be there, part of the system, for as until the system matures. You have to have enough people involved so that there's enough voting power that not, not so that it doesn't allow for anybody to just come, sort of mine the voting power, and then be able to take over. The Tellor team at the beginning, basically we act as a referee to make sure that the system stays clean until it is mature enough for us to basically walk away. Once a dispute is initiated, an XCM message goes back to the Tellor core parent chain so that they can hold their stake on an escrow until the dispute is resolved. But all of this process should not affect the user. If they need the data, they just have to request it again, and then they'll get their data faster. They don't have to wait for the resolution to happen. And that's how it works for the user. We are currently on the testing phase of this architecture, and we're going to be starting with testing on a private chain, private testnet. What I've heard from my devs, we're going to be using Rococo for testing. And once we actually go through the entire cycle, because of the XCM messages, we want to make sure that the latency is not too long, and that we really can't test that on our local machines. It's just, we want to make sure that we get a real sense of how long it's actually going to take to do all of this with 2 chains. I know he just talked about IBC. We're happy to look into that once it's actually live. But this is our original implementation, and I'm really interested mostly on finding out what people are building, how often and how quickly do they need the data on their chains, and then also just in terms of attack vectors, making sure that the XCM messages work the way that we intend them to work. In terms of the economic incentives associated with our design, we have been live with this design for almost 5 years now, so we're pretty happy with the design in terms of other chains. But this is our first take at a multi-chain environment, and we're super happy to be here. We're also learning as we go. It has been a little bit different than building 4 EVM chains. Obviously, once on EVM chains that are already deployed, you know exactly what to expect, you know how they work, versus parent chains, whoever is the owner of the parent chain can actually change a lot of levers. It's very modular, including how much actual space is allotted to your palette, and that can have an effect on like some of the for loops and some of the things that we actually have to do to make this work. So we've had to adjust that, and the way that we're thinking about it mostly is we're gonna have to just come up with specifications so that whoever is implementing the palette knows what we need or knows what is required to be able to run it efficiently. So that has been sort of like a change in mindset, because it just makes it a little bit more difficult. But it's also really important that we do this. I think that in general, in the traditional space, there's so many relational databases that we've been using for years and years to actually accomplish what we do, and they become very, very specialized, obviously, because we need them to just do a specific purpose. And we have billions of that in the general world. So it's just naive to think that one open network or open ecosystem was going to be able to support the type of engagement that we're trying to get from, or adoption that we're trying to get. But it's absolutely necessary that we start thinking that way, and this is our first shot at it, so I'm so happy to be here, and I want to learn from you guys. Whatever you guys are building, let me know what it is. Hopefully this works. I want to be able to start testing at the end of the summer. We're already on the testing phase for the local stuff. When I was in Copenhagen, we were deploying the private testnet. So hopefully by the end of the summer, we will be on real testnet and be able to test some of the projects that are out there. So thank you. That's pretty much it for me. And we are Tellor on Twitter, and you can follow us there or join our Discord if you have any questions. So that's it.
Thank you, Brenda. Thank you. We got 4 minutes for question. Somebody has some question about Tellor? Yeah.
Hi. I'm quite curious to know a little bit about where you store data. So you have some bursts which are submitting data. You are not storing them directly on chain, right?
Yes.
So where are you storing them, in IPFS or another kind of storage?
No, the data goes straight on the data on the parent chain.
Okay.
The definitions for the data, is that what you're talking about? Or?
No, I'm really talking about the data which are submitted, because basically at some point you will get a lot of data being submitted.
Right.
So that will probably take a lot of space, which is not necessarily a good idea for blockchain, I mean.
We're not loading the MLS or huge amounts of data. Currently, most of the use cases are for DeFi, and they're generally like some sort of aggregated price information, like a TWAP or like.
Okay, so a few bytes each time or something like that.
I'm sorry.
A few bytes per bunch of data, I would say. Or
it can take a little bit more than a few bytes, but yes, in general, you want some sort of data that can be, read and decoded, and then do something with it on chain. So if you're trying to load what for prices, let's say you need the ETH USD price. As a user, you would define, I want it from all of these sources, and I want it aggregated in this way, and that might be a lot of data. And what happens is everybody has this definition, so they go and do the off-chain computation, which is more intense, and they come up with this just one number that is actually reported. And then anybody can validate that because everybody knows, and go and dispute it. So you're not loading like all of the exchange data and all of that information. So that's mostly right now what the use case is for oracles on DeFi, is mostly pricing information, or small things like maybe, who won the election, which is something that you can just put in, or who won the game, was it, whoever, the Redskins, or I'm sorry, that's not even a team anymore, the Cowboys or whatever, that's easy to load. When you're talking about loading like full states of like a blockchain, like you can do a Merkle tree that is a little bit more manageable. And there is a lot of research already going on into how to actually load a bunch of data. You don't actually load it, you can load the proof of it and make it available, and then people can verify that the proof is correct. The hash should be the same.
Yeah, that's clear. Thank you.
Yeah, thanks. 1 minute and 30 seconds.
Oh, we got another question maybe?
Thank you. Thank you, Brenda. In the Tellor wallet, there is a component associated to the oracles. And my question is, this element in the definition is closed, or it will be possible to use different oracle providers?
So it's open. Anybody can become an oracle or a node or a data provider as long as you stake. And a stake allows you to provide data once every 12 hours. So if you want to provide a lot of data or be able to provide it more often, you have to stake more than once. But it's open to anybody. Like, you can be a node, I can run my node. I run one for testing on AWS. I don't really run it to make money. There's a lot of competition to get those rewards. So what people do is they'll take our base client and they'll improve it, make it more efficient, and they implement it in their closed source, and then it's very competitive. But anybody can run it as long as they stake and run the client. Yeah.
Thank you very much,
Thank
Brenda.
you. Thank you, everybody.